guys, hey, thanks for checking in and watching this video. This is a video that corresponds to lesson 9.2 in your textbook, which would be page 476 if you're following along. Have some paper and pencil handy. Definitely, as always, going to want a calculator. And I'm hoping that once we get going with this lesson on prime factorization, that you're going to realize that a lot of this is review, right? A bit of a blast from the past. I'm guessing that near the end, when I sneak in some more algebraic type ideas, that will be new learning for you, but I'm thinking that the first few slides will be review for you. So let's talk about prime factorization, which requires the use of prime numbers. What are prime numbers? A prime number is a whole number that has exactly two and only two, no more, no less, factors. And the factors would be 1 and itself. So if I'm thinking about prime numbers, I'm thinking about numbers that can only be divided by 1 and itself. So I've listed some of the prime factors here. It's certainly not all of them, but 2 is a prime factor. What can 2 be divided by? 1 and 2. That's why it's a prime number. 3 can be divided only by 1 and 3. 5 can be divided only by 1 and 5. 7, the factors of 7 are 1 and 7. The factors of 11 are 1 and 11. And 13, 1 and 13. So on and so forth and so on and so forth. And I got all the way up to 41 and I decided to quit there. There are certainly many, many more beyond 41. But we're thinking of numbers that have only 2 factors. Only 2 numbers that it can be divided by. And that it would be 1 in itself. Well, what about the numbers that aren't prime? They are called composite. Composite numbers are whole numbers that have more than 2 factors. So they can be divided by 1 in themselves and then something else. So if I'm looking here at this list of composite numbers, I look at 4. What can go into 4? What can 4 be divided by? 1 and 4 and 2, right? So it has 3 factors, 1, 2, and 4. That's what makes it composite. Let's jump ahead to 9. This is an interesting one. Lots of kids think that 9 is a prime number. It's not. It's an odd number, but that doesn't make it prime. The factors of 9 are obviously 1 and 9 and 3, right? So it has 3 factors. Jump up here to, let's say, 15. What are the factors of 15? Well, there's 1 and 15, obviously, and 3 and 5, right? So these are the factors of these composite numbers, and you'll see that they all have more than 2 factors. And there are way more composite numbers higher than 22, as you see in this list, but I ran out of room, so I stopped there. If you notice, the number 1 is not contained in either list. It is not prime, and it is not composite. It does not fall into either definition, because what are the factors of 1? It's just 1. So technically it only has 1 factor and does not fit the definition for either prime or composite. So 1 is kind of an oddball number, and for the most part today 1 is off limits. You'll not be using the number 1 when we are factoring. Let's talk about prime factoring, and this is what I think should be a blast from the past. Prime factorization is when you take a composite number and you break it down into a list of prime numbers that can be multiplied, I guess, together. I'm trying to figure out the best way to say this. You're going to take a composite number, you're going to break it down into all of its prime factors, and then what you're going to see when you do that is if you multiply all those prime factors back in the end, you'll end up back where you started with the composite number that you started with. So check this out. I'm going to prime factor 20. All you have to do is think of any 2 numbers that multiply to get 20. Now remember I said you can't use 1. 1 isn't going to get you anywhere. So you could use 4 and 5. You could use 2 and 10. Anything goes. I say 2 and 10. Now, as soon as you list factors, which I just did, if it's a prime number, circle it, because that's a dead end. And 2 is a prime number, so it doesn't go any further. 10 is composite. So 10 we have to continue to break down. What times what is 10? No, you cannot say 1 and 10. How about 2 and 5? 2 is prime, 5 is prime. So the prime factorization of 20 is 2 times 2 times 5. Those are all prime numbers. And those are all the factors, the prime factors of 20. Guess what you get if you multiply 2 times 2 times 5? You get 20. That's how you can check to be sure that you're right. So we see that we have 2 times 2 times 5. Well, a better way to write this, since there are 2 2's, is 2 to the second power times 5. That is truly the best way. Hey, where's my eraser when I need it? There you go. And this would actually be your final answer. 2 to the second power times 5. Let's try some. Oh, nope, I forgot. We have to talk about what a monomial is. We're going to see these a little bit more near the end of the lesson. A monomial is a number, a variable, or numbers and variables stuck together. So 80 is a monomial, right? It's just a number. X is a monomial because it's a variable. 8x is a monomial because it's the number 8 stuck to the variable x. They're stuck together using multiplication. Those are all monomials. The next one down, this right here, x plus 5, that's not a monomial. That's a binomial. It actually has 2 parts. It has an x and it has a 5, plus 5. This one, x squared minus y squared, also not a monomial. It has 2 parts. It's technically a binomial. So these are monomials. Yes, yes, and yes. It's like one term. It's another way to think of it. And real quick, then we end with this definition. To factor as a verb means to write a number as the product of its factors. And we'll get into this a little bit more near the end of the lesson, but they do throw an example at us, so we'll talk about this real quick. Here we have to factor this monomial. So what they've done in this long list here, they've taken the 6 and they factored it into a 2 and a 3. So that's where that 2 and 3 come from. They've taken the r to the 4th and broken it down into its 4 individual r's. That's where this comes from. And then they took this s and stuck them on at the end. Since there's only one s, you only need one s in your list. So we are going to be factoring these monomials here in a few minutes. Let's go back to the first topic we discussed. Is it prime or composite? Well, you have a list, so that should help. Or you can always just think to yourself, how many factors does this number have? So think about 15. Is it a prime number or is it a composite number? What can divide into 15? Well, there's 1 in 15 and 3 and 5. So this is a composite number. How about 23? What times what is 23? What are the factors of 23? 1 and 23. Nope, nothing else. That's prime. And it should be on your list. How about 37? What times what is 37? Well, there's 1 in 37. Anything else? Nope, there's nothing else. That makes it a prime number. Oops, there we go. And next up, 22. Well, there's obviously 1 in 22. Oh, and 2 times 11. That is a composite number. All right, so a lot of that's just going to be a matter of looking at that list that I provided. Let's practice prime factoring. Let's see if you can do this. What times what would be 90? And you could start anywhere. You could do 9 and 10. You could do 45 and 2. You could do 3 and 30. I like 9 and 10. Neither of those is prime. We have to break them both down. 3 times 3 is 9. Those are both primes. And 2 times 5. Prime and prime. So the list would be 2 times 3 times 3 times 5. But you're an 8th grader now and you know how to use exponents. So you're going to tell me that that is 2 times 3 to the second power times 5. And that is the final answer. Let's do 24. What times what is 24? Did you say 6 and 4? Did you say 2 and 12? Did you say 8 and 3? Any of those will work. I chose 6 and 4. Break down 6, 2 times 3. Break down 4, 2 times 2. So how would we write this? 2 to the third power times 3. Final answer. Some more room here. Ooh, 104. What times what is 104? Well, it's an even number. You can always divide by 2. 2 and 54. That's prime. 54 is not. What times what is 54? Well, it's an even number. Oh, I put 54. It's supposed to be 52. Oh, boy. Oh, boy. How about this? Is that better? That's better. Anyways, 52 is even. Divide it by 2. And 26. Prime. Not prime. Even number. Divide by 2. And 13. Both prime. 2 to the third power times 13. Final answer. We'll do this last one. I like 2 and 99. I like 3 and 33, which breaks down to a 3 and an 11. All those are prime. So it's 2 times 3 to the second power times 11. Final answer. That, hopefully, is a review. Last thing before we're done. Factor these monomials. Ready? Break down the 10. 2 and 5. So it's 2 times 5 times x times y. Done. Break down the 12. 3 times 4. And 4 becomes a 2 and a 2. So it's 2 to the second power times 3. We have 2 Q's in the list and 3 R's. Ooh, we saved the best for last. When you have negative monomials that you need to be factoring, your first step is to take out a -1 and stick it out to the side there. Now once you factor out a -1, pretend that that's a regular old positive 18. I just prime factored it. So when I write my list now, I'm going to write a -1, a 2, 3 to the second power, 1m, and 4. Yes, I said 4 n's. Final answer. Got to bring out that -1. Happens again over here on this last example. Bring out that -1 and hold them out there to the side. Now treat 35 as if it's positive. 7 times 5. So it's a -1 times a 5 times a 7. That'd be 3 C's and 2 D's. And that's how you prime factor a monomial. Whew! Nice work. This is what we're going to be working on in class the next time I see you. Take care.